Let's look at first principles. So we will find the derivative using first principles. We're given our equation f of x is equal to 3x squared here, and we will find the derivative using first principles. Now, when the instruction is to use first principles, you must start with the formula for first principles, and that formula is f prime x is equal to the limit as h approaches 0 of f into x plus h minus f of x all over h. Now, I've separated this formula into a red part and a blue part. So the red part, the first part of this formula here, it means wherever you see x in the equation, you're going to replace it with x plus h. So there's an x here, 3x squared, so instead of x, I'll replace it with x plus h, so that becomes 3 into x plus h squared instead of 3x squared. Then the blue part, you're going to subtract whatever f of x is. Now f of x is 3x squared. So I'm going to subtract 3x squared. All I do now is I open out the bracket. So 3 into, this is squaring the binomial, so x squared plus 2xh plus h squared minus 3x squared all over h. Open out the bracket here. Using distributive law, that becomes 3x squared plus 6h plus 3h squared minus 3x squared. Put your like terms together and you'll notice that 3x squared subtract 3x squared will cancel each other off, and I'm left with 6xh plus 3h squared. Okay, that's equal to the limit as h approaches 0. You can pull out a common factor of h. So it's h into 6x plus 3h all over h. Your h's will cancel now, and you're left with the limit as h approaches 0 of 6x plus 3h. Now you can substitute 0 for h. So you'll end up with your answer of 6h as your f prime x answer. 6x as your f prime x answer. Let's try another one. F of x is equal to negative 4x squared minus 3x. Remember, for the first part here, f prime x is equal to the limit as h approaches 0 of f into x plus h minus f of x all over h. For the first part on the top here, wherever I see x, I will replace it with x plus h. So there's an x here, negative 4x squared, and there's an x here, negative 3x. Those two x's will be replaced with x plus h. So it's negative 4 into x plus h all squared minus 3 into x plus h. For the next part, I will have to subtract whatever f of x is. Now f of x is negative 4x squared minus 3x. So I will subtract what f of x is, which is negative 4x squared minus 3x. And because there's more than one term, you have to put that in brackets here, because you're subtracting the entire thing. So open out all your brackets, square the binomial again, you'll get negative 4 into x squared plus 2xh plus h squared. Open out that bracket, minus 3x minus 3h, open out that bracket, plus 4x squared plus 3x. Open out this bracket using distributive law now, and you'll end up with negative 4x squared minus 8xh minus 4h squared minus 3x minus 3h plus 4x squared plus 3x. Put your like terms together. Again, you'll see that negative 4x squared and positive 4x squared will cancel each other off. There's a negative 3x there and a plus 3x. Those will cancel each other off as well. So I'm left with the limit as h approaches 0 of negative 8xh minus 4h squared minus 3h all over h. I can pull out a common factor on the top, so the limit as h approaches 0 of h into negative 8x minus 4h minus 3 all over h. Cancel my h's off. I'm left with now the limit as h approaches 0 of negative 8x minus 4x minus 4h minus 3. Substitute h equals 0, and you will end up with f prime x is equal to negative 8x minus 3.